All right. You're with me? Here we go. Here's what we got. I finally figured out how to do the how to pause a recording, which is nice to know. I didn't know that before on this nice little intuitive machine that we have here. Luckily, you can find out anything on the internet. I always forget that, so I just start plugging. I just start punching things, clicking on things, and swearing. That's my modus operandi. Anyway, here you get the energy and the power. Now let's talk about a generator. Big old magnet spinning around the thing here. All right, so since it's going around in a circle, the magnetic field is always changing. It's going maximum. You know, it's going through a cycle of maximum orientation to push the current down the wire, which we'll learn about in the next chapter how that actually works. But they're just throwing this AC circuit, this alternative circuit to us. Okay, so it follows a nice little sine curve, and so the voltage at any time is equal to the maximum voltage V naught or negative V naught times the sine of 2 pi times the frequency. We run on at a frequency of 60 hertz, and I think overseas they run at 120, so they double it. So when you come back from overseas and you land at, you know, JFK or something like that, it always seems kind of it's a little bit fuzzy because your eye actually picks up that frequency difference. This looks hard, but it's not. It's not. And so I is equal to the maximum, since the current voltage V over R. Now R is not affected by this. It is not. It's always the same. R is a constant. It's always the same. So I is equal to the sine times 2 pi times the frequency too. And this again is the peak current is I naught. And so the power, when we multiply these two together, we get the sine squared of 2 pi times the frequency. Okay. Which means it's always positive. But it's also always changing because now it's the sine squared graph. But we can just cut it right in half and get the average power, which is the peak output and the peak voltage multiplied together divided by 2. And so then the root mean square, the average power is equal to the root mean square voltage and the root mean squared current. What do we mean by the root mean square? That sounds complicated. It's not. Here it is. It's pretty straightforward. So VRMS is equal to V naught divided by the square root of 2. That's all we're saying. That's it. Okay. IRMS, the root mean square, is equal to I naught divided by the square root of 2. And this is only for AC, alternating current. All right? And then the equations still are valid. VRMS is equal to IRMS times the resistance. Resistance is always constant. Okay? And then the peak power, peak, is equal to V naught times I naught. Okay? And then the average power is equal to VRMS times IRMS. All right? That's it. That's it. That ain't nothing. Nothing to be afraid of. Nothing to see here, folks. All right? That's a good old, there we are. And then the average power equation still holds. Okay, so let's take a look at this problem. It says a stereo receiver applies a peak voltage of 34 volts. So P power is equal to 34 volts. I'll let you all see my work here in a minute. The speaker behaves approximately as if it had a resistance of 8 ohms. Okay, so R is equal to 8 ohms. Determine the RMS voltage. Okay, I can do that. I can determine the RMS voltage and the IRMS current and the average power for this circuit. Okay. Well, that's pretty easy, because what I'm going to do is I'm going to start with problem C to start with, because I know the average power. Here we go. You can say, all right, well, I need to find VRMS, IRMS, and average power, which is equal to this. Okay? Piece of cake. 34 watts. Did it say peak voltage or peak wattage? Oh, the peak voltage. The peak voltage is, man. I about really screwed that up. Okay, so I can also find the peak power and all that kind of stuff. So V naught is equal to 34 volts. Okay. Ergo, the peak voltage, it may or may not equal the peak, but anyway, we can figure it out. We can figure out that the I times 8, that's going to be my peak current too. And now when that happens is kind of funny, but we're not going to worry about that. In fact, we don't need to do that chapter. So 34 divided by 8 is equal to 4. I naught is equal to 4.25 amps. So therefore, the VRMS is equal to 34 divided by the square root of 2. And it's always that, because it's based on the sine curve, not multiplied by, divided by. Is equal to 24.024 volts. The IRMS then is equal to 24 divided by 3 divided by 8 ohms. I was thinking ahead of myself. This is VRMS over, which would be 3 amps. Okay, and then I said that now I hope that's correct. In other words, if I take 4.25 divided by 3, I've got to get that turned off. 4.25, because sometimes my daughter sends things that are not. Divided by the square root of 2, let's see if that equals 3.0. Yep. So I feel pretty confident that we got this right. There we go. And the average power would be 72. Cool beans. The peak power would be 144. All right? We good with that one? I'm good with it.